Alright, hello everyone. We're going to look at the PowerPoint notes for Lab 8, Anaerobic Power and Capacity. So the purpose of Lab 8. This lab will determine anaerobic power and capacity from the Wingate cycling test and anaerobic power from the Margarita-Kalaman step test. Anaerobic is defined as living without oxygen. Next slide. Anaerobic power is determined by the ATP supplied by the creatine phosphate system. So there's the reaction shown there. Creatine phosphate plus ADP yields ATP. ATP and PCR are important energy sources during high-intensity exercise. So your blank there is high-intensity exercise, lasting only a few seconds. It is indicative of stored energy in the muscle. So your blank there is stored energy. Anaerobic capacity is determined by the ATP supplied by the glycolytic pathways. So your blank is ATP and glycolytic pathways, rather than the rephosphorylation of ADP by the CP system. It is indicative of the individual's ability to utilize the glycolytic pathway as a source of ATP during high-intensity exercise. Next slide is the glycolytic pathway. It is a more sustainable source of ATP than the CP system. You don't need to memorize that reaction, but have an idea of what that looks like. So, glycolytic pathway, more sustainable source of ATP than the CP system. Comparison. CP system is faster but less sustainable source of ATP. CP system is faster but less sustainable source of ATP. Glycolysis is slower but more sustainable source of ATP. So if you look at the table shown there, it shows the CP system, which is immediate energy stores lasting only a few seconds. The next system is the glycolysis that peaks a little under 60 seconds. And then it also shows the oxidative pathway, which is used for sustained energy production. Why not store ATP? Next slide. The ATP molecule is heavy, weighing 507.18 grams per mole. A typical human will use approximately 100 to 150 moles of ATP per day. So if you work through that math, that means we're using over 76 kilograms of ATP per day. 76 kilograms of ATP per day. So it wouldn't be good to have a weight fluctuation of 76 kilograms, right? That would be a bad thing. Next slide. Exercise and effects on the ATP system. Maximum anaerobic power reached during the first 4 seconds of exercise. Remains constant during seconds 4 through 6. After the 6th second of exercise, energy output declines steadily due to decreased ATP and CP content in the working muscle. So your blanks there are ATP and CP. Because of decreased supply and maximum rate of splitting of ATP and CP, maximum work rate at highest intensity can be achieved within 3 to 5 seconds. So your blank there is 3 to 5 seconds. Next slide, why is it important to determine anaerobic power and capacity? It helps us determine muscle fiber tendencies and identify the types of activities an individual may be best suited for. Fiber type distribution is crucial. 3 major human muscle fiber types. We covered these in lecture, so these should be review. Type 1, slow twitch oxidative, lower power output, highly oxidative, very fatigue resistant. Next one is type 2A, fast twitch oxidative glycolytic fibers, moderate power output, oxidative and glycolytic, moderately fatigue resistant. And the third kind is type 2B, fast twitch glycolytic, high power output, glycolytic, and low fatigue resistance.